just realized I ate carrots. Have we gone black? Hey, everybody. Are we live? Yep. Hey, everybody. Kent Martz here from Explore Scientific. Didn't get the normal cue I get, so I wasn't sure we were live or not. And boy, I am hot on the monitors.
You will not.
Wowzers. Hang on, folks. We're having focus trouble and exposure trouble. It's just all bad. Oh, it looked like it was in focus. Getting there. That's, well, I'm looking way behind too, so. Okay. Yeah, there we go. Okay, so today is, I'm still not in focus. No, there we go. Boy, I'm hot too. Woo-hoo-hoo. I've been outside, but I'm hot because the lights are bright and the exposure's not good. So here we go. Going on down the road. We've only got one camera set up, so I'm going to be looking off at an angle right here. We'll get the other camera set up. We had power go off last night right in the middle of a broadcast with Annie and Tyler and Scott. We were right.
They were never on.
Were they never on? They didn't get up?
No, we didn't. He went off right before.
Power was off for, I don't know, pushing an hour here, and it just shut down. I mean, kaplunk. And so we all just went on home because you never know how long it's going to be on for, right? So today is Friday. That's Focus on Astrophotography. So if you've got a digital single lens reflex camera, or heck, even a film camera, but a lot easier in the digital world, if you've got a digital camera, you can start doing astrophotography right now. You can do it tonight. Well, I wouldn't do it tonight necessarily because you've got just past a full moon, and the full bright moon will be up all night. But you can start learning how to use the camera, right? So with astrophotography, you have the ability to have longer exposures, which let faint light into your onto your camera sensor. And tonight, if you've got a tripod, you can go out and point it to the south and start taking pictures of the Milky Way with whatever lens you have. If you've got a zoom lens like this one, a 24 to a 105, you can shoot Milky Way shots with it. Obviously, the moon's going to get up and interfere with that just a wee bit, a whole lot actually. So in another 4 or 5 days, you'll be able to shoot for a couple of hours after it gets dark and start taking pictures. But if you want to go that next step and start taking pictures longer than maybe 10 or 15 seconds, there's a way to do it. And the way to do it is with something like this right here. When I set this up, I set it up backwards. I'm going to spin this around real quick so it's oriented correctly.
Pro tip, Ken.
It doesn't matter.
You don't draw attention to anything that's not working correctly.
Paul says, pro tip, Kent, don't draw attention to things that aren't working correctly. I wasn't drawing attention to it. I was just talking about a mistake I made. Life goes on. So you've got a camera and you get a go-to mount. This is a go-to tracker. So this will follow a point across the sky. This mount right here is called the IEXOS 100. It is a very, very powerful device, yet, interestingly enough, it's a very, very simple device to use because we engineered it and planned it that way. So, to make it point out what this does, this is a clutch. It's not a lock, it's a clutch. The mount turns in rotational axis, rotates this way, which is the axis the Earth turns on. This is called right ascension. And this axis right here, got to turn the clutch. This axis right here is the declination. It's sort of up and down. Think of it as up and down. And this is around and around. This mimics the rotational axis of the Earth. So what we do is we get this thing what we call polar aligned, right? We want this axis right here pointing at the north or south celestial pole. The first way you start is you figure out how far north of the equator you live. Here in northwest Arkansas, we're 36 degrees north. So right here, right there, on that scale right there, we're going to raise this up and down by turning this knob right here till we get to 36. And we're actually just a smidge over, and you do the best you can with it, right? And so once you've got that done, aligned, then you've got to do get it pointed north. Well, you got to, if you can see Polaris, you can do a decent job of getting it close. And you can actually look through this little hole right here that goes through called the polar tunnel, and you can look through it and see the the Polaris, which is very close but not on the north celestial pole. Otherwise, use a compass and find where north is, and obviously you have to understand the difference between magnetic north and true north. If you live here along the Mississippi River like we do, we're 1 degree west, so it's off just a little bit. Doesn't matter that much for us. Farther west you can get 15 or 16 degrees off, and the farther east you get on the coasts of the United States, you get way off. It's the same issue in lots of other countries. Magnetic north deviates from true north by a lot based on, you know, things going on in the earth, metal and other things, right? So you have to know that and account for that, because if you just use a compass and point it north, you're going to be, and you're say in Sacramento, California, you're going to be 14 or 15 degrees off, and none of your go-to slews are going to be accurate. Okay, so I'm going to show you how this works. You've got a camera. You need something like our digital singular DSLR camera adapter. This is designed specifically to be used on a astronomical telescope mount, and you simply just somebody's been messing with this. We've got to screw it back in a little bit. That little bolt will screw out if you get it in the right spot, so you can change it between this slot, and this slot, so you can achieve good balance. Well, I happen to know that about right there will achieve, hang on, how do I want to put it on there? I want to put it on there just like that. When you tighten down the bolts that hold this dovetail into place, you want to do it on the metal side. I'm making sure that's what I'm doing right there. So I am doing it on the metal side, and I've done this enough that I know about where the balance point is. So I'm just going to use this little paint bucket bail handle on top of this nut or a bolt and tighten it down. And if you really want to get tight, you can use a coin or a screwdriver, and I think I'll do that. The tighter you get it, less chance you have with the camera weight pulling it off to one side. So I'm going to really tighten this down with a very handy little dime that just happened to be laying here. There we go. That's tight right there. So that's not going to come off very easily. So here we go. We're going to put it on the camera, and of course, I put it on the wrong side because I didn't make the mental flip. I tried to, still didn't do it. So we're simply going to loosen that up, spin this around, slide it back down a little bit, and then tighten it back up. No big deal, right? Learning is all part of the process to make mistakes. So this is just simply going to go on right here, and I'm always going to make sure I have a really good grip on it when I get it in here, because I don't want it falling down. Now I'm going to tighten it up, tighten down the safety nut, safety bolt, and voila, we have this camera now mounted pointing north, because we're in the northern hemisphere. Our friends in the southern hemisphere that may be with us would be pointing it to the southern hemisphere. And so here's what we're going to do. We're going to fire up our iPad. And on our iPad, we have downloaded a program named Explore Stars. That's the application that communicates with the computer mount, the computerized portions that are built in here, the processors. We can hook up to this wirelessly with an Apple iPad, an Android tablet, or a Windows tablet. They have to have a screen of at least 7 inches. Soon that will be go away, and you'll be able to use an iPhone and an Android phone, but that's probably a couple of months down the horizon. Osmosis 007. Howdy, Internet people. Howdy, Osmosis 007. So we're going to get it pointed north. We've polar aligned it, and we're ready to go. It's real simple. I'm going to double tap the button on the iPad to make sure that Explore Stars is not running in the background. And if it's not, or if it is, I just flick it up and it's gone. I hate chunks of dust. Let's see. So now I'm going to go to my settings. I'm going to go to Wi-Fi. I'm going to tap PMC8, and this is unit number 6358. That's the name of this mount. Each one has its own name. And now I'm going to hit connect. I'm already connected to it because I've connected up before. Oh, you forgot the fill the tanks with fuel. Hopefully not, Pekka. Hopefully not.
Keep going.
So I'm connected. Do we have anything on the reserve tank? That's what gas stations are for, isn't it? So I guess there's something else popping up here in just a minute. Oxidizers, yes. Liquid oxygen, we're working on it. I'm not sure what they're talking about. They may have a side conversation going.
Now they're talking about the one camera and stuff.
Oh, the one camera stuff. I think we're back to 2 cameras now. Paul was working frantically to get it rearranged. So here we go. I'm going to launch Explore Stars. And if everything has gone well, I'm going to be able to use the home page comes up with a virtual joystick. What you give it to grandma's mower. What you give it to grandma's mower. And there it is. It moves. So if we've given it.
Kent is not in the mood for.
Call Elon and Borto for some electrical engines. I don't know what they're talking about.
They're talking about our stuff that went awry.
Well, let me tell you, the push mower definitely hit liftoff. Grandpa laughed, Grandma not so much. Yes, I always liked the old rotary mowers with the sickle blades where the rolling actually made them turn. Boy, those things were a workout, weren't they? Okay,
yeah,
so I'm going to
Kent's not in the mood for tomfoolery today.
I'm still lost here. What? Over my head. just like that over my head.
He's not going to let me have a good time and poke fun at him.
So I'm going to go solar, sun, slew to object, and go to. There it goes. It's going to go out to the sun. Now we're inside, so we don't really have to worry about the sun frying the electronics in the inside of our camera right now because we're inside. If we were outside, we'd make sure we had a solar safe filter right here to keep any excess energy from going into the camera and frying everything because it's going to build up heat and it'll fry the sensor and the electronics. It'd be very, very bad when that happens. So, hey Noah, would you run and get me an ED80, please? I just realized I did not grab one. Mm-hmm. You can probably get Andy or Tyler to show you which one it is if you're not sure.
I got the 127 or 107.
102.
102.
So,
whatever it is.
Well, the one you have is the one you have, and it's 102 or 107 or 701 or 10201.
The 694.
No.
Okay, the 694 special edition.
Paul's wandering around on the stage. It's like the experiment where we talked about it yesterday, where they passed a basketball around between players who were wearing red uniforms and white uniforms, and then asked and told them to count how many red players in red uniforms caught the ball, and it was all awesome. And then they asked him, okay, what color shirt was the gorilla wearing? And they said, what gorilla? Or somebody walked through the entire set with a gorilla costume on. Nobody saw it. Very, very few would ever see it because they're concentrating so much. He's the gorilla just walked through the set. And if you focus,
If you look, they're looking at that.
Yeah, I know.
See?
See, they're looking at that C. Yeah, that C. So, if you want to do some solar photography right now, real simple, use the sun catcher from Explore Scientific. Obviously, this one's just a wee bit big, so you probably wouldn't want to use it, but you could if you wanted to. It comes with these hard foam triangles that you cut down.
You're going to run out of gas
to fit, and it just goes just like that. And these hard foam pieces keep it in place. We can now do solar photography with the sun catcher and take pictures of the moon. Now, with a 105 millimeter focal length lens, the sun's going to be really, really small because the sun.
What was happening is Pekka was watching my clock.
Here we go.
As it counted down.
Osmosis 007 says, all conversations were before the live started. That explains why I have no idea what you guys are talking about. So I see the tomfoolery. Paul knew that it wasn't connected to the show, and he was just
It
throwing
was
it out
connected
there.
to the show.
Well, only in the sense there was conversations while the show was going on. All right, so anyway, this is a 105 millimeter lens. The sun is the same diameter of as the moon is. So, you know, pinky at arm's length, 105 millimeters is not going to do much. You're going to have more focal length than that, or use a telescope. We'll talk about that after a while. So one thing I want to tell you about is if you're going to use a zoom lens, I highly recommend that once you get your zoom set, like on this one, out at 105 millimeters, you use gaffer's tape or painter's tape or something to tape this down, because otherwise it's just going to go down on its own. And if you don't realize that, you're going to be really upset after you start looking at your pictures and you've got this nice 24 millimeter. Thank you. You just did it right back there, Noah. Thank you, sir. Noah just brought us a nice ED80 to show you here in a little bit. So Noah was on the
what's
screen.
the difference?
Is Noah back there hiding behind me? Where'd Noah go?
Yes.
Noah's back there. There's Noah. Hi, Noah. How you
So-
doing, man? So go ahead.
I'm curious.
Curious Paul.
I
We could write a
know
book,
the
Noah.
answer.
No, we could write a book. Curious Paul.
I don't have a tail, so there's that.
What you got? Waiting for your idea?
So, which one do I have again?
You have the AR-102.
Okay. No, I have the ED version.
I think it's an AR.
No.
Okay.
It says
It's-
ED on the
Okay,
side.
so then you got an ED-102.
I thought it was something else. Anyway, why? These guys all know it, but if we have somebody who doesn't know what they're doing, or is new to the business,
There you go, new to it, learning.
that's one, that 8080 and the one that I'm using. What's the difference? What is the main reason?
A little bit longer focal length. And
That means
it's a longer focal length, which means
what does?
you're going to have a little bit more magnification power.
Okay.
And it's, what would it be, 24 millimeters in diameter or larger, which doesn't sound like much, but it's probably over half, again, much light coming to your sensor. So you get more light coming to your sensor. It's like a garden hose versus a fire hose, except in reverse. You know, a garden hose puts out make it put out a good stream of water, but a fire hose puts out a whole lot more water. Why? Because it's bigger around, right? If the pressure is equal, the fire hose is going to put out a lot more water than the garden hose does. Well, a big around telescope collects up more photons than a little around telescope, right? Or same with the camera lens, and they gather up more light, and that more light gives you a brighter image. Now you get into some other math. The focal length gets a little longer.
I did that.
I figured you did, otherwise all the other lights would have gone off and the broadcast would have shut down like it did yesterday. So anyway,
it did shut down yesterday, that's for sure.
it just went boink, and that was it. So Paul's sitting there playing with toys, trying to mess me up. He's doing things to, yeah, can you even tell the light went off? I bet you can. Yeah.
yeah.
I got a nice shadow over here on this side.
Yeah.
I sort of
But
like that shadow.
It's too much of a shadow for what you're doing.
Yeah. But
So
I
for
sort of-
some reason, I guess when the power went out yesterday,
Mm-hmm.
it kind of messed with my light settings, so I'm using my Bluetooth over here to fix them.
he's playing with his toys. Indeed he is.
You
So,
get to
we're
play
gonna-
with your toys every day
That's true.
on
for an
Amazon.
hour and a half.
Yes.
So it's sitting here tracking the sun across the sky. Now, if we've got a good polar alignment, it's going to stay there. You may
Much
have
better.
to you may have to move it a little bit left and a little bit right, left, right, up, down buttons. Once you get it centered where you want it, just hit the sync button, and now you've told it, I'm pointed at the object it went to, in this case the sun. I'm centered on it, and now it's going to track that across the sky. It's going to use the RA, the right ascension, the round and around Earth portion and the up-down portion called the declination to track that across the sky. That's perfectly fine if you're doing fast exposures like the sun, because you're not doing slow exposures on the sun because it's still very bright in solar safe filters. However, if you're doing it for astrophotography, that system of sync, you're running both motors, eventually is going to present a problem. This mount is powerful enough to overcome it by learning, right? And we don't need to go into that process right now, but you learn it. You know, you learn more things, and you build your skills up, and that's what it's about, right? So, this is the IEXOS 100. It's the -02 model. It does have built-in Bluetooth. However, that Bluetooth doesn't interact with anything right now until we come out with the Explore Stars 2 or Explore Stars Plus, whatever we're going to call it. And then that app will allow you to connect to the mount via Bluetooth, and your device will also be connected up to the internet. Here we go. The studio must be experiencing very poor viewing condition. All the lights keep twinkling. Yeah, Osmosis 007. That's Paul being a goofball. Hey, that rhymes.
Whatever.
Paul and goofball.
Hey, check this out.
Hey, check this out.
Since we're not on Amazon yet.
We're
Let's
not.
see.
We're on the social media stream, so we can talk about things other than Amazon.
So I could make my lights do a bunch of weird
Oh
stuff.
no. Oh no. Disco Paul is going to come out.
It's a lightning. Right? No,
I
it's
did not
fireworks.
see it.
That's fireworks. See? And then lightning right there. Trigger. It's lightning. So we can use this for our
I can sort of see that as lightning. Yeah, okay.
we could use this for our Halloween special.
Oh yes, that would be fun. I'm gonna start twitching if you don't quit that.
Lightning.
Lightning, camera, action. Yep. Paul's just having too much fun. It's Fun Day Friday apparently.
What the heck's going on?
I don't know. There's
Noah's doing the same thing.
no. It's not Noah. Noah's not here. What's going on with the lights in here?
Somebody's doing it.
So somebody's messing with. It's just lights everywhere flickering. That was just bizarro. I don't know. There was nobody at the switch. Were you not doing that, Paul? With the room lights? Yeah. It's craziness. It's insanity. Oh boy, we have gone off the rails this afternoon. But hey,
Having a little fun,
as long
Kent.
as we don't touch the third rail, it'll be okie dokie. Because never, Paul, never touch the third rail. You know why?
Depends on what you're talking about.
Well, that's where the fun's at. It's the third
Depends
rail.
on what you're talking about.
Well, it's where the electricity comes from on an electric subway system. Yes, the third rail. Don't touch it. Very bad. Very, very bad. So,
Do we even have the Amazon Live loaded?
don't look at me. Not my wheelhouse. So, we can do other stuff with this. It's not just go to the sun with this. We can do things like, if it's night, we can go to Messier objects. We can go to catalog, Messier. What are Messier objects? Charles Messier, Chuck Messier, Chaz Messier was the French court astronomer in the 1600s into the 1700s. He was looking for comets because the nobles thought comets meant change of reign. And so if there was a comet coming, they would protect themselves with their most loyal troops until the comet was gone and then go along their happy, merry way. They didn't know what comets were. Telescopes were not well developed yet. And the glass was, Coke bottle glass is better than the glass they had. So Charles Messier, even though he had no light pollution, zero light pollution at night, he saw these things, they didn't move, so he knew they weren't comets. He started writing those things down. He and his wife as an assistant. and they wrote down these things up in the sky that don't move. List of 110 objects. They became known as Messier objects. I grew up calling them Messier because it's Messier. You guys have to read the whole thread.
Here it comes. Wait,
Honest questions
a
on
little bit
Barlows. What's the big pro and cons of using them? Osmosis 007 asks. The pros and cons of Barlows. I'm going to talk about focal extenders. Barlows and focal extenders are slightly different. They do effectively the same thing. They're like magnifying glasses, and they come in 2 power, 3 power, and we sell them at least in 2 power, 3 power, and 5 power. So that means if you're looking at something at 25x and you put a 2 power Barlow on it, it becomes 50 power. So it'd be the same thing using a 12.5 millimeter eyepiece instead of, say, a 25 millimeter eyepiece. Okay, whatever. I'm just talking numbers here. So if you add a 3 power Barlow, that would be 150. And if you add a 5 power Barlow, that would be 500 whatever. So it's over 600 power. So the benefit of it is you get longer and longer focal length, which gives you much more magnification with the same eyepiece. So if you had a magnification of 25 and you went to 50, it's going to get up above 600 with that same eyepiece in there. So that's a benefit. It works really good on planets, as you know, because planets are small, and people who do planetary astrophotography generally take videos and then pull out the best whatever percent, let the computer analyze them for sharpness and focus, and then use the ones that are good and then stack them up. Works well. The problem is, on many nights, you also magnify the scene. And if the stars are twinkling, you're going to magnify the planet, and it's going to look terrible because it's jumbled up and jumping around on its surface, just like the stars nearby it are twinkling. If the planet was a pinpoint of light, it would twinkle too, but it's not. It's a big circle of light, but yet the air that makes this star refract light is making a point on as it moves across the surface, moves between you and the planet, and it's the atmosphere of the Earth. It's doing this number all over, and the air next to it is doing this, and so the whole surface of the planet is going like this in all different directions. That's why it looks bad when you magnify it. So there's some pros and cons.
The best way to explain that is the highway deal I was talking about yesterday.
Yeah, you know, Paul's example is when you look out across the highway and you see heat waves coming off, and it makes a mirage if you're at the right angle, or it makes the trees and buildings and fence and cars and whatever just look like a blob. The example I like to use is a swimming pool. When it's good scene, you know, if there's no wind and there's been nobody in the pool, it's glass clear. You can see the bottom. You can see little flecks of dirt on the bottom, tiny little leaves. You know, it's just, you can see everything in the pool. Well, you slap your hand on it, it makes it a little bit harder to see in the pool. And if 5 kids are playing in the pool, it's all just jumping up and down. So, Paul, we gotta get off for a minute?
Well, you just got to go to Amazon.
Oh, it's time to go to Amazon. All right, so we're going to go ahead and go down for a minute and then
park
pop
your
up on
scope.
Amazon. I'm parking my scope as we speak. So we're going to go to Amazon. Park, catalog settings, park scope. There we go. So while we do that, we're going to flip over, launch the Amazon program, and then come back up on the live stream. So I'll be talking about Amazon, but the live stream on social media is going to be up as well. See you in a few minutes, everybody. I'm good. You didn't cue me there, Captain.
I thought you
Twice.
were watching.
Twice. Now, you could see me looking down, fiddling with the cameraman.
I was busy getting the stuff.
I was not fiddling with the cameraman. I was fiddling with the camera, comma, man. Hi, everybody. Kent Martz here from Explore Scientific.
You want to pull up the Amazon comments?
Yep, going to get the Amazon comments up so we'll be able to see. We are on Friday's broadcast of Focus on Astrophotography. Astrophotography is where amateur astronomy is headed. Because of light pollution, lots and lots of people, especially people live in big cities. You know, if you live in a city of a couple, 100,000 or 500,000 or 1,000,000 or 6 or 7 or 8 or 10 or 20 million people, you have light pollution. If you live in a big city, you can't see very many stars, like maybe 12 or 15, including the planets on any given night. You can't see the Milky Way. Hey, Noah, could you twist that around a little bit more this way for me? You can't see the Milky Way, but you can do some astrophotography. Much better, thank you. There was a glare on it, Paul. So.
Do you need your own hair and makeup?
Actually, yes. I had to spend about 30 minutes in the hair just getting my hair done. It's so exhausting, I'll tell you what. So, love me. In fact, it is about time to get a haircut, for sure. So, got a question coming in, it looks like, from James Dugan. Hey, a down under fella. He's down under the equator in good old Australia, Sydney, Australia. Hey, James, do you consider yourself below the equator or above the equator? Just curious. Let me know. Good day, Kent and Explore Scientific team and everyone in the chat. Welcome to this episode, James. Nice to have you with us. Here on Amazon Live, you've got the carousel over there that talks about a lot of the products we're going to be talking about. It's Focus on Astrophotography. Astrophotography is becoming a bigger thing, and with the use of specialized filters, we're not going to talk about them today, but you can get specialized filters for your telescope or your camera that cut out all the light except a wee bit in a very narrow band or a couple of narrow bands that allows you to ignore the light pollution and go do some astrophotography. From Pekka Howdies from Stockholm, Sweden. We truly have an international audience here. This is always fantastic. I know Beatrice joined in on yesterday, right as we were showing off. I saw Beatrice Hines from Belgium weigh in. That was awesome as well to see everybody here on the broadcast. All right, so
Osmosis, I think, is somewhere in the United States.
Osmosis is in the United States. I can't remember where. He may be on. He'll tell us here in a moment. So, if you've got a digital,
James has an answer to your question.
James Dugan, below. There we go, below the equator. I didn't know if if you got on the southern hemisphere, if you felt like you were on top of a ball that rolled over, okay.
Is that myth of the water running backwards?
The Coriolis effect?
Is it true?
No. Well, there is a Coriolis effect that on a very large scale can affect things. But what affects the way the water rotates in your bowl is the way it was engineered. Because you can't, in fact, in science demonstrations I do for a nonprofit I'm on the board of, how do you, if you take 2 soda bottles with a connector, if you just set them down, the water won't switch places because the air pressure in the bottle reaches the same water pressure and it just sits there. And you can squeeze it and make it go down, and we'll talk about this and demonstrate. And then we'll get it spinning, and we'll spin it, and it'll start a vortex, and kids will call it a whirlpool. And it'll start a vortex, and then the vortex goes down into it, and water starts going down, and there's a little hole like a straw, and air comes up through it. That's what lets it equalize. Well, that spinning action is very important in all our lives because that's what makes toilets flush. And if you ever flush them and you see that spin is not induced by the rotation of the earth. No, it's not. It's induced because when that toilet was built, the water that comes out from under the rim doesn't come out straight down. It comes out at an angle, so it starts that spinning action, gets that vortex going, and you can move a whole lot of water real easily through a hole, in this case, a hole in the bottom of the toilet. And there you go.
Water sticks to itself.
Through.
So because of that,
what's the term called? Why water sticks to itself?
Adhesive properties. I don't know.
Nope.
Tell me, Kent.
Surface tension. Water has a surface tension. It creates its own
it does
film.
that too, but it also kind of sticks to itself.
James Dugan, you guys have the galaxies. We have the best nebulas, so the south is better. Interestingly enough, many of the comets that are discovered by people close to the equator or in the southern hemisphere has to do with the way they come in from outer space. So, Paul, what were you saying?
Nothing.
Oh, okay. Oh, that water sticks to itself. Yes, it does. That's why in space, if you squirt some water out of a bottle, and you can see examples of this all over from the International Space Station or back in the Space Shuttle days and even back to Apollo and Gemini, they squirt water out. Well, in microgravity, it just becomes a sphere. It sticks to itself and makes a perfect sphere. It's really weird to watch it undulate sometimes, and it's got movement. The thing undulates. It's just so
Jello.
cool. Like, an amoeba almost. It's really weird. But
Jello.
okay, Jello. What color Jello would it be?
Clear.
Clear, very good. Watercolor. So,
yeah.
Anyway.
What if... No, I can't say that. Never mind.
Never mind. All right, so focus on astrophotography. Back and focus a little bit.
Focus it a
Who's
little
that
bit.
over there?
Focus.
Who is that over there? Is that Nick? Hey, you want to come be on TV, Nick? Come on, man. Nope, not Nick. Not going to do it. Nick works out in the warehouse. He makes our box and displays
makes the sun
and
catcher.
things like that.
He makes the sun catcher.
He actually does. He assembles the sun catchers and does a.
He also makes them.
He designs boxes and display stands, and then tells the computer how to the CNC computer how to cut the cardboard out. And you see this thing that
Scared
looks
him off, Kent. He'll never come back in here again.
Back in. It's you actually will see Nick on some of our advertisements for outdoor products.
Yes.
Rifle sights and binoculars.
Huh? Said I should pull that up.
Oh, might be able to get a picture, and we're going to show you what Nick looks like. So, anyway, he might not be here, but we can get him here in photographic likeness. So, anyway, you've got a DSLR, a digital camera. You can start doing astrophotography right now. You can get a tripod, point the camera south, set the ISO to 2000. Set your f-stop to f5.6, leave your shutter open for 30 seconds, and then go inside and process it. There's no processing other than the process of sticking the computer and looking at the picture and see what the picture looks like. And if it's blown out, go with a shorter exposure. Change it one thing. Do science. Don't change two things. Go to a shorter exposure or lower your ISO and just see what you can do.
If you're using a camera, close your aperture.
Yeah, or close your aperture, which is going to cut down the light.
I suggest closing the aperture first, because it will make, not only will it make the picture more less exposed, it will also make it sharper.
The problem is many times people get underexposed to begin with, and stopping down is going to affect that. But
don't stop it down.
That's why you take a picture and then go look at it. Now,
if you're looking at the moon, you're using 150 shutter speed anyway.
I say 250. There you go.
150 to 250.
One 250 at f5.6. I think it's how bright the moon is.
No.
Something along that line.
No.
Yeah.
No.
Yeah. Not
Which
gonna wrestle about
it depends on camera to camera, because the ISO is different. The native ISO of the camera, so like that Canon right there, its native ISO is probably 500. But the camera that we're using to film you on, its native ISO is 800, which affects the
What would the
f-stop.
what would the native cameras be in Australia? Those natives, the Aborigines.
Yeah, they're not cameras. Those are people.
They're people. Yeah, different
Yes.
thing. Okay, so yeah, back to cameras. Go out and try it. Set your shutter speed. Set your f-stop.
Try
Point the camera at the sky.
F250, not F250,
was gonna say
but shutter
F250.
speed of 250. You can do that if you want. With a f-stop.
Not if you're shooting the Milky Way.
If you're shooting the moon.
I'm talking about shooting the Milky Way.
If you're going to do the Milky Way,
Yeah.
you
30
can do
seconds.
a 10-second exposure with the 50mm lens at about 800 ISO, f-stop of about 8.
And then see what happens. My point is,
That'll do it.
experiment, right? Got to experiment. There's no one answer.
It
There's
depends
no,
on the camera.
There's no easy button. It
If it's an
depends on the
old camera,
camera.
it's gonna
It
take
depends on the lens. It depends on
Yep.
lots of things. So we can't tell you what's going to work with your camera. But sneeze number one. Okay. So we're going to shove off and talk about cameras a little bit,
What
not
did
not
you
debate
say?
theory. I said shove off.
Are you saying something to me?
No. I'm saying we're going to shove away
Are you
from what
trying
we're
to
talking
tell me
about
something?
and get on down the road pitching
Trying
product.
to tell me something?
Pitching product. We want to pitch product.
We
a
need
little
to
bit.
entertain.
This is
and
a
pitch
sales
product.
channel as well. Yes, but I'm not Polly Shore. So we're going to shove
That
off.
would be very strange if you were.
Yes, it would. Okay, so here we go. We've got
All right.
a 10-year-old Canon camera. It has a zoom 24 to 105. I'd say start where you want to and see what you get. A 24 millimeter is going to be a really wide shot of the sky. I'm going to say probably zoom in a little bit, but just start where you want to start. My one piece of advice is once you decide where your zoom you want, you need to tape that ring down with painter's tape or gaffer's tape, because as you can see right here, it's starting to go down, right? And it'll do that over time, and you're going to ruin your pictures. You're not going to like your pictures. So tape that down, and once you achieve focus,
Potty
huh?
wants to ask a question, and I'm saying yes. Please.
I can't
come
see
answer
very
the
much on my
question.
screen because I have my extended protection ends soon, Paul, over on the laptop. So
Well,
I'm going to
just
slide
go
over
over
here
there
and
and
click.
hit it.
I'm going to walk over there and tell it to go away.
Good grief.
Walk off camera. Of course, you got to make the mouse move. There's the mouse. Close. Oh, good. Nothing blew up. Nothing stopped. Success. All right. So
There's
here
your
we go.
question.
The question. Hazarapati.
Huzzah.
Hazarapati. Does anyone still use hybrid film, or is everyone using CCDs? CCDs or CMOS sensors, one or the other, I think, are absolutely the very dominant. Is there someone out there who's still hypering, Tri-X or Pan-X film with liquid nitrogen? Probably. I can almost guarantee somebody's doing it. But, very difficult process to do. Oh, man, I'm sorry to make you walk over there. No, you weren't it. There was a big warning box about something expiring. I just had to click off. So don't apologize. We're glad you're asking the questions. So he's asking a question about a process that started up in, I guess, the 70s and 80s, where you would chill your film down to super cold temperatures by using liquid nitrogen. By film, I'm talking about 35 millimeter film typically. And then you would run it through the camera, and that hypering process, making it really cold, made it super sensitive to light, so you could get effectively longer exposures without having to increase the exposure because the film was sensitive to light. And then you would process it normally. That's the process I'm familiar with, and actually attempted and just discovered. Luckily, I was shooting so much film, I bought it in 100-foot rolls at a time, and then bulk loaded my film. So I discovered that I just froze the film. I hypered it so much with liquid nitrogen that it turned brittle, and I just broke it. And that was a mess inside my camera when the film broke inside the camera. Learned that lesson. Never really did get the technique down. Didn't have any mentor or anybody else to help me. Was reading about it and in a sky and telescope, and didn't really understand the process, but tried it anyway, and there you go. James Dugan, CMOS is the future in astrophotography, in my opinion. I think that's probably the case. CMOS chips, CCD chips started it. CMOS chips have really accelerated and are much cheaper and more flexible. I think there's all sorts of benefits people find to CMOS chips versus CCDs. But sooner or later, James, I'm going to predict, maybe not in our lifetimes, but there's going to be something come along that will improve on a CMOS chip. They may be out there right now. I know there are some cameras out there that have insane hyper range, ISO range, where you can take pictures in the dark and see people like they're perfectly exposed, but yet you can see nebula and stars and things in the background just glittering just like they look in the sky. So, there's progress is happening all the time. But I keep saying, if you've got a digital DSLR, digital single lens reflex camera or single lens camera, you've got a way to start taking astrophotography right now. So you're going to put it on the mount, and you can put it on a tripod through the 1/4 20 hole, point it to the south, take pictures. But very quickly, if you want to up your game, you got to start doing something else, and you're going to be thinking about, okay, I want to take longer exposures of something that tracks the object across the sky so I can leave the shutter open for a minute or 2 or 3 and not get streaking. That's going to put you into something like the IEXOS 100. This is over in the carousel right now. This is a go-to tracker. You can control it with a tablet, an iPad or an Android tablet or a Windows tablet with a screen of at least 7 inches or a Windows desktop or laptop computer. You do it wirelessly with an app called Explore Stars. You can also use your Windows machine to wire directly into it. And after a certain level of learning doing astrophotography, we here at Explore Scientific highly recommend that you use a wired connection versus wireless, because it's just so much more robust. Some guy down the street turns his microwave oven on or his ham radio, and it fries your connection and you lose your control. That can be bad and cause problems. You've got a wired connection, you're golden. It's solid, it's stable. Nobody can hijack it from you, so that's what we recommend. So you got an IXOS 100. It's a go-to tracker. Not only does it just have a clock drive that you point it at your object and it tracks across the sky, you can actually polar align and have a go-to system in which you tell it where you want to go and the mount goes there. How do you use a camera on it? Because, telescope mounts use typically something that looks like this. Finding one of these is hard. We found a few of them that were like 2 inches long, and you just couldn't balance your telescope very well on the mount. So we came out with the DSLR camera adapter, real simple to use. It has a little screw on it that screws into the 1/4 20 hole in the bottom of your camera, or if you have a big lens, your big lens may have one on there too. I'm going to use a dime in this case. Coin works well. Dime is what we had. So to tighten down that screw, and I'm going to get it as tight as I can get it without going all Tyler Bowman on it. Tyler was one of the customer service guys here. He has been working out a lot. He is pretty darn strong, and he can tear things in two by looking at them, but that's for another day. So he would twist it all the way in and break it. So here we go. Real simple to slide on here. I've got the locking screws on. I'm going to slide it in on the metal side. See, it's got two sides. One has some measurements so you can take notes of where things balance. I'm going to slide it in here, and I know from experience this tightens down about right there. I'm going to get a hold of it, and now on one hand on everything, and so it can't slide until you get tightened down real tight. Now that I've got it tightened down. So let's talk about what this mount does and how it works. This is its rotational axis, just like the Earth has a rotational axis. And this axis right here, right, is the rotational axis of the Earth. Just like the Earth rotates, that's that. That's the right ascension. This is sort of up and down. It goes around and around. That's called declination. It's sort of up and down, not exactly, but we're going to call it that. So I'm going to point this north, and how am I going to do that? I'm going to polar align is what this process is called, and this process involves having to know where true magnetic south or magnetic north are. For James Dugan, he doesn't have any stars close to the south celestial pole. So this method we're getting ready to show you on a little video we have is going to teach you how to polar align using a compass. Well, in the northern hemisphere we have Polaris. It's very, very close to the north celestial pole, but hey everybody, Kent Martz here from Explore Scientific. Today I'm going to teach you how to polar align your telescope using a broom. Why do you need to polar align? Well, with a telescope that has an equatorial mount, you have to get that equatorial axis lined up with the rotation of the Earth. And to do that, we're going to start with the tripod. We're going to decide which one of these legs is going to point north, and we're going to set the tripod down so that leg is pointed north. First thing I'm going to do is use a level to make sure my tripod is level. So if it's tipped one side or the other, that's going to cause your polar alignment to not be accurate. So we're going to use a level for that purpose. Then we're going to take a compass, and just to make sure that I've got it pointed north, I'm going to use the compass, line up, and go, yep, that looks like it's pointed north. So here's what I'm going to do now. And this is where the broom comes in. The broom becomes a measurement device, if you will. So I'm going to put the broom on the ground with the tip of it right against the north leg of the tripod. And I'm going to back away, and I'm going to use the compass. I'm going to close one eye, and I'm going to use the compass to make sure that the broom is lined up with north, right? And so I can tell I'm off just a little bit. So I'm going to move the tripod just a little bit, and I'm going to turn the broom, and the broom is what I'm seeing that line with to line up. So closing one eye, now my broom is lined up perfectly to magnetic north. Right here is we're going to talk about something called magnetic declination. The magnetic north is not true north. The difference between true north and magnetic north can be off by as much as 15 or 16 degrees if you live on the east coast or west coast of the United States. Around the world, it varies. And you have to figure out what that is for where you live. Because if you point at magnetic north, you're not going to be pointing at true north. You can be off by 15 degrees. Your go-to will never be accurate. So for this system to work, you have to know what that offset is and be able to program that into your compass. We're going to provide a link to a website and a video that talks about that a whole lot more. Now, we're going to make sure that the tripod is not angled wrong. I'm going to use a small tape measure, and we're simply going to come down here and be careful not to move the broom, and I'm going to measure the distance from the tripod leg to the center of the broom. That is 470 centimeters. That way, it is 470, a little, I'm going to call that good. Actually, I'm going to move the tripod a couple of millimeters, just like that. So now, we know that we're lined up true north with that leg, and these two legs are the equal distance from right here. So it's not pushed that way or that way. So now that we have the tripod with a good alignment to north, we have to put the head on the mount. And that's going to entail this. We're going to be very careful when we do this, because we don't want to move the tripod. We're going to put it on and simply screw on the polar head just like this. Remembering everything's going to the north. Now if you're in the southern hemisphere, you're going to do the same thing. You can do the exact same in the southern hemisphere, because it's not polar, it's polar alignment. We just don't use the star Polaris. which we're not using here. This is really good if you can't see Polaris, or if it's daytime and you want to do some solar viewing with a solar safe filter. So the last step of this process is to check the scale of your altitude, right? So we live at 36 degrees north, and I am going to turn the altitude until it gets to 36 degrees north. I'm going to stop, and that's it. With this system, using a broom, a compass, and a tape measure, you can achieve a good, decent starting polar alignment. Personally, I've used this. I've got an amazingly close polar alignment. There's ways you can use to refine your polar alignment, specifically drift alignment, but it all starts with a good polar alignment. You can do this in the daytime. You can do this in the nighttime if you can't see Polaris. It works all the time. It's a good way to get started learning the process of polar alignment. Isn't that great? I hope you've enjoyed this video. For Explore Scientific, I'm Kent Martz. Get out there and start doing astronomy. And keep looking up.
Kent, what's wrong with it?
I checked it. Give me the batteries.
They're over there,
No, they're
on the wall.
They're not on the wall. They're right behind you, Paul.
Why, Kent? Why?
Because rechargeable batteries get to be less than stellar.
So
after a certain
Kent
point.
says he checked his microphone. We'll
Roll
see.
under your desk, Paul. So, this is comedy routine right here. We're planned it out so it'd be funny.
Not really.
Yeah.
That's what happens when you have one guy running everything.
Hey, there you go. Batteries. I guess Tuesday or Wednesday, the base station ran out of power. And this time, the belt pack ran out of power. It became powerless to do anything. All right, so here we go. Where were we? Now you know how to use a compass to get yourself a good starting polar alignment. And there's somebody named Gail out there. Hello, Gail. Thanks for letting us know that I was apparently lip syncing to the sound of silence, but we have the sound back now. If you're new to our Amazon live stream, this is Explore Scientific. We talk about astronomy and telescopes and birding and educational toys, all sorts of stuff on 2 o'clock Central Times, Monday through Friday, with a lineup of different shows. Today is focused on astrophotography. We're talking about astronomy. So there you go. Hi, YW. Nice to see you out there. We appreciate it. James Dugan, all good. Now, cheers. Yes, indeed. The crowd roared.
I don't know why there's always something wrong.
Because it's live. You know, we don't have a host of producers and directors and camera operators. We have a host of you and me. You know,
I get busy.
And every once in a while, Tyler and Annie, and as Noah comes in to pinch hit every once in a while. Noah is Marketplace, Noah Marketplace Menard. He just gave us a wave. It was like this today. Just like that, he looked up and smiled. Noah keeps the Amazon platform and other marketplace platforms up and running. Does a great job. Really is making it a vital part of the company. So if you're new to us, there is a follow button, and we'd love for you to click that follow button if we have earned your trust, and we hope we have. We're all users of our products. We're not just somebody hired to sell stuff for us. I work here full time. I do amateur astronomy Don't do much astrophotography. Have before.
What's wrong, Kent? You keep looking off camera. What's going on?
Process. Huh? I'm thinking.
What's
I'm looking deep. I'm looking deep into my past, seeing my childhood out there with my dad, with binoculars out in the backyard in a green wicker chair in the late 1960s, looking up at Comet Bennett or Comet West and watching meteor showers. Great memories of growing up doing amateur astronomy with my dad. And, you know, do those things when you can, because after a certain point, you can't do them with your dad anymore because he's not around. So make those memories with your kids, won't you please? Anyway, we've got a camera attached to a go-to tracking mount, and this is the IEXOS 100. I've got it set up with an iPad screen of at least 7 inches to make our app work. It's called Explore Stars. Will it work on devices with screens smaller than 7 inches? Yes, you may be able to get it to load and operate, but the buttons are too small and they won't work. So we try to apply scaling functions. That won't work. So we're doing some rewriting of the graphic user interface to make it work on iPhones and Android phones. When this program was developed 8 or 9 years ago, iPhones were still not, and smartphones weren't nearly as ubiquitous as they are now. Tablets were the de rigueur way to do things, and that's changed, and we're trying to keep up with that as well. So click that follow button. We would like for you to do that. And thank you, everybody, for sharing your time with us today. So I want to go take a picture of an M object, a Charles Messier discovery on his list of 110 things that weren't comets. M3 says it's up, so I'm going to M3. Here's what it tells you. It gives you all sorts of information. M3 is a globular cluster of stars in the northern constellation of Canis Venatici, which is up near the Ursa Major, or the Big Dipper. It was discovered by Charles Messier on May 3, 1764, and resolved into stars by William Herschel around 1784. So it took 20 years for telescope technology to go from all it is a faint little fuzzy ball to, oh my goodness, those are actually stars really close together. So a whole bunch more information goes on for 4 paragraphs. How far away is it? 33,900 light years away from Earth. So when you look through a telescope and see M3 through a telescope, those photons landing on your eyeball are 33,900 years old. They've been traveling at the speed of light for 33,900 years, and their destiny, from the time they were created, in whatever star created them, their destiny was to land on your eyeballs right then. You just absorbed 33,900-year-old energy into your body, and you'll have that energy in you. We and the stars are connected. And in fact, we are made out of star stuff. That's a whole nother show. But all the heavy, if you have gold earrings on it or gold wedding band, guess what? That gold was made in another star that exploded, and all the material got recycled back and eventually became Earth. Really cool to go through that process as well. So,
you know what we need to do? We need to
right now you've got a please wait message up.
Yeah. We need to be able to show them this stuff. So instead,
we can do that.
Well,
you have to do it wirelessly. You have to have a dual connection. If you could have a wireless connection and a wired connection, you could do it right now.
That's what I'm telling you.
You want me to disconnect and see what happens? See if you can do it?
Let's see if we can do it.
Okay, folks, we're going to do something live on the air that is asking for a disaster, but you know what?
Why not?
We're brave enough to do it. So I've turned my Wi-Fi off.
Where do I go?
I'm going to turn the battery off so it comes back on. You're going to go to your wireless.
6358?
Yeah, PMC 5368, password. Shh, don't tell anybody the password. It's very secret. I'm just going to share it with you people who are watching right now. It's uppercase PMC dash PMC and, or all uppercase, dash uppercase E, and then lowercase, spell the word 8. PMC dash 8. That's the super secret password. It's not secret.
Let's see if I can get a hold of it. Do 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 do
you'll have to shut down your app and relaunch the app.
Okay, do it.
Because that please wait message. Ooh, that's crazy looking.
Isn't that fun?
Look, an infinite number of me. The world is saved.
Or destroyed.
Or destroyed.
Great peril at this point.
It probably
there it is.
Grape peril.
Grape.
Okay, so click on catalog. Okay, so this is different than the up in the top left-hand corner, I think. I'm gonna walk off screen real quick.
I think what it is, I don't think
No,
I
it's
have
there.
the.
No, it's there.
I don't have the.
It runs different. Move your graphics in the way. There you go. Up in the, click the menu up here in the far corner, right there. Yep.
How do
They
you do
can't.
that?
They can't see it over there.
Okay. Let me just go
No,
straight
app can't.
here.
No. There you go.
Merge. Oh, wrong way. Merge. So this is the interface.
Yes. So, explore stars, settings, preferences. We're going to make sure they're all set. Use JRH doesn't matter. GPS is on. Night mode is on. Debug is off. That's fine. Log target data doesn't need it. Your longitude and latitude is correct. Scope IP doesn't matter. Change the scope type from G11 to IXOS 100, and everything else is the same. So hit the back arrow, and
I may not have the catalog loaded.
no,
in
you
the
do,
right
because
place.
otherwise it'd say data file's missing. So click app bar. No, that's not it. Click app bar. There we go. Now go to solar system objects. Do we have it on the mount? Yeah, so click sun. Click.
Right, hang on. Auto. I got to change cameras if we're going to do this.
Okay, so here we do.
And now.
Y'all are watching this live here. Okay, now
Yeah.
click slew to object.
And merge. That way you can watch them out. There it goes.
There it goes. That's all it is. People struggle. I mean, it's they try to make it a lot more complicated than it is. But there we go. You can see right here. You're watching this live. Brilliant idea, Paul. Now the Windows app is the oldest version. It's not been updated.
Yes.
So there have been some new commands and things issued. So I haven't messed with it much. We know that fewer than 10% of the people using the EXOS 100 use the Windows. The majority use a Apple tablet, an iPad, or then followed by Android tablets, then followed by Windows operating system. We know those numbers, and it's under 10% use Windows. So there we go. So Paul, click live on the screen, click Messier. So app bar. App bar. Are you clicking the app?
Go to Target. Target info.
No.
Clark.
not-
App.
App.
Got it.
Messier.
Okay.
Pick one. Scroll down through there and pick one that's above the horizon. It shows you what's above the horizon and not above the horizon.
Is the red above or below?
I don't know if we're broadcasting or not, because I'm seeing focused on astrophotography. Are we down?
Shouldn't be.
Because I'm not seeing anything on my monitor. I'm not seeing you on my monitor. No, can you come bang on this? May have lost it on the computer. So, go to Messier object, pick a Messier object, slew to it.
Let's see. Hang on. No, we're broadcasting.
Okay, because in my screen it just is the opening credit, focus on astrophotography.
Yeah, I'm still streaming.
Okay, so pick a Messier object and then slew to it.
It won't let me. Let's see. And it's not one. It's not up in the air. Which ones are up in the air?
The ones that look at their names.
Well,
M3. I know M3's up because we went to it.
There
it
we
goes.
go.
What'd you go to?
Leo.
Something in Leo. Nope. It's going to clear by 1/4 of an inch. So what are we going to in Leo? What is it? M what? 70.
Leo triplet. Leo triplet. That's what I'm going to.
There you go. That's how it works. Now, it
did a polar flip, didn't it?
It did a polar flip, changing hemispheres, pointing to the northeast. What'd you say, Noah?
I said that's so cool.
Noah said, "That's so cool." Absolutely. So the Windows, as I said, is the oldest version, followed by Android, followed by Apple, the iPad version. The iPad version has had some upgrades in the way things operate, but the interface is roughly the same. And if you're thinking about buying an iOS 100 and you have a Windows tablet or a Windows machine or an Android tablet or iPad, you can download the Explore Stars app right now and start playing with it. You order the mount. When it comes, if you've been playing for 4 or 5 days with the interface and have found all the buttons, you already know where those things are, and you're much farther along the road because then you can hook it up just like you saw Paul do, and boom, off you go. You're ready to go and ready to start using it.
So taking a tour of Leo.
So what are we looking at now in Leo?
Regulus 7?
Regulus. It's the 7th brightest star in Leo. No, it's the brightest star in Leo called
Now we're going to
Regulus.
move to Al-Ghaiba.
Yeah, there's a lot of Arabic names.
And then Messier 95.5? Yeah. So
Yeah.
I'm just taking a tour
Yeah.
of everything that's in
It's
Leo.
just so cool. And it's just easy. I mean, you saw Paul, who has never done it before, did it with just a little bit of help. And now,
I just needed to know where things were.
yeah.
That's
yeah.
all.
But
Because
once
I'm
you-
used to the iPad
Yeah.
version.
So, which is a little different. And, it takes a little bit of time to learn where, things are called and where they're located in each version. But there you go. And so if we were now taking pictures, we'd be taking big old blurs because we're going to be taking 1 or 2 minute exposures here if we can. And Paul's not staying on these objects long enough. And so we're not
I'm
taking
showing
pictures.
the mount move.
Yeah.
We're not actually. Well, we can take pictures of the roof.
Well, exactly. No, this would be the ceiling. We have to be outside and take pictures of the roof.
Pluto's up. Is Pluto up?
Pluto is
It's
not up. The moon's not up. Mercury and Venus are up. They're the only planets that are up right now.
So there we go. Let's go to Mercury. So it's going to go all the way back around, isn't it?
It looks like it's heading to do it's doing a meridian flip.
Meridian
What
flip,
is a
that's
meridian flip, you ask? Somebody out there, I think Gail must have been, 3 minutes ago, she says, "I see you." My computer that I see the monitor on had just apparently lost its internet connection and went kaput. So somebody out there asked, what's a meridian flip? Well, when you face south and due south and draw a line straight over your head all the way up to due north, that's called the meridian. That's the highest point in the sky. And so if you're pointing at something in the southeast, eventually the mount gets turned or such a way that it's pointing to the west. To get better tracking, you want to get it back, point it over there. So the point over there has to turn itself all the way around and do what's called a meridian flip. And now it'll point that way and finish turning itself down, following it across the sky. So after you cross the meridian, when it goes and it's flipping, it's because you've crossed the meridian. Now, some mounts automatically do it, the EXOS 100 and our PMC8 system, which is the name of the system that runs this mount, and the Exos 2 GT. I'm throwing a lot of data out there. It's the PMC8 system. That's the name of the system. It doesn't do a meridian flip. So how do you do a meridian flip easily? Well, if you did a go-to to that object, after it crosses the meridian for 10 or 15 minutes, stop your picture and then just execute another go-to. It'll automatically know it's on the other side of the meridian and it will flip itself around. very smart. So let's talk about how does
So,
this mount work? What you got, Paul?
Osmosis says it's definitely easier than a hand controller.
Definitely looks easier than a hand controller. I've used my brother's, and the button memorization is insane. Yes, this has, you know, there are
Can
people.
you see the comments now?
I can see the comments now, yes. So, James Dugan, it's a nice interface. I like the solar system in the picture and the shots of the DSOs and the constellations with the locations of the DSOs. Yes,
Deep
packed with
space
information.
objects.
Now, the Windows version shows the solar system. The Android and Apple does not. There's just differences in the way things were implemented.
Yeah.
So, talking about the interface and the hand controller, there are some people who are so locked in to the hand controller that
I may have broke it.
Did you break it?
Yeah.
This battery.
No, the app.
This battery is, well, should have
It's
enough.
the app.
So the app, you crashed the app. He has so much running on his. If I was going to be doing this for astrophotography, I would be running as few programs as possible. So he lost. He's got broadcasting and editing software and switches and all sorts of things on there.
I'm running 1, 2, 3, 4, 5, 6, 7, 8 programs right now just to make the show work.
Yep. Plus running.
Plus this.
Plus a wired internet connection, plus a Wi-Fi connection to the mount. So relaunch the mount, reconnect to it, and let's see what happens. Huh?
I've got it.
Okay, park it now. Let's see if it knows where it was. It may or may not. Sometimes this will work. It'll be in settings probably. App bar. It's been too long since I've used the Windows version. I use the Android version and the iPad version almost exclusively now. So did you tell it to park?
Yeah.
Okay, so we lost the connection. We reconnected.
We didn't really lose connection. I accidentally tried to load an extra database that I did not have access to.
But it shut the app down, right?
No, it just crashed it.
Well, yeah, it shut the app down, so it lost connection, but it still knew where to go to get back to where it started from.
Yep.
The park position. Look at that right there. Okay, so go to some other places while I talk about it. Go-to mounts, let's talk about the hand controller. People have used the hand controllers since the 70s and really into the 80s hard, and then in the early 90s they came out with really what would be considered really good, modern, semi-accurate go-to.
The Crab
that
Nebula.
Have a hand controller that numbers and buttons and left and right and up and down, and lots of people are tied into hand controllers. Okay, when I got a phone that you could type on, you had to, I got buttons, right? Everything had buttons on it. Well, when I saw an iPad, I thought there's no way, or an iPhone, I was like, there's no way I'm going to be able to do this without buttons. Osmosis 007. Yes, the biggest problem I had with the hand controller is I'm still new, so memorizing the M and NGC objects was completely overwhelming. Absolutely, we tried to change that as well. So we use some modern graphical technology to show you pictures and make it what I think to be pretty intuitive. Well, people used to buttons and the tactile feel of buttons aren't used to no buttons on their screen. Well, how am I going to find them? You look down. Okay, so they'll be using a telescope with a diagonal looking down. They said, well, I don't know where my buttons are. Well, okay, here's my easy answer for that. Let's say that I'm looking into the diagonal, right? I'm left eye dominant. I never use my glasses. I'm left eye dominant. So I'm looking in the telescope, okay? So I use my right eye at the telescope and I hold, right? I'm at the telescope. I hold the tablet so I can hit the left, right, up, down buttons, and then I'm at the telescope looking in there. I get my fingers where I want them. I close my left eye, my dominant eye. Now only my right eye can see through the telescope, right? Nope, can't get it like a monocle. It's close.
What was that you were doing?
Trying to get them like a monocle.
You got dentures today?
So I haven't had my pills, my vegetables. So I close my left eye. Now I can only see on my right eye, and I press the buttons left down. If I need to move my thumb, I open my left eye, close it, and go on down the road. If you're right eye dominant, you set up so you're looking through the telescope with your left eye, right? So this is the eyepiece. And I open my right eye, and I can see the tablet.
Hit him with it.
I get my thumb ready. I close my right eye. So now I'm looking through the telescope with my right eye. I got my thumb where I want it, and I just push the left, right, up, and down buttons. If I need to see where my thumb is, I open my right eye. I look at the tablet. I position my thumb. I close my right eye. I'm looking through the telescope again. Voila. You don't have to have tactile buttons to be able to use a hand controller. If it's something new to you, yeah. My kids can type, well, what they consider to be full sentences and abbreviations for words without looking at their phones, right? I can do some of it a little bit, not like they can, but when I started, you know, back in 2006 or 7 maybe, 5, 4, I don't know when I had that. I remember, it wasn't a BlackBerry, it was something else. Don't remember what it was called. Anyway, I had buttons on it, and I thought I'll never be able to use a device without buttons when they came out. Now I can do it with no problem. If you want to make the switch, you can make the switch from buttons to no buttons, and it brings up a whole host of other things. And if you've ever used one of those hand controllers and tried to go through using and reading where the stuff crawls across the screen, that is 1 or 2 levels of Hades right there. That's close to crossing the river Styx. It's agonizing to read sentences. It's like, you need to press into.
What are you doing?
And when those words are ant crawling across that little one-line screen, you don't face this when you have a tablet. You don't face it when we're going to have an iPhone or Android phone. It's a functional tool. It's great. And as you can see, Paul's over there making this thing dance. He literally has never used that app before, and he understands it. It's very intuitive. So what makes this mount good, great, okay? The motors on it, on the old systems, were servo motors. You apply power to them, and man, they go full bore, and they go, and they go, and they go. If you run into something or hit something, they don't care if the power's still applied. They're going at full torque, full bore, and they're going to tear up gears, chew up gears.
I was trying to hit you with it a little while ago.
Sir?
I was trying to hit you with it a little while ago.
No, you can't, because I've got the table. I mean, it misses it by about a quarter of an inch, maybe less.
I was trying to hit you in the head with it.
Oh, you can't. If you had a long enough telescope, you probably could pull that off. Yeah, a really long telescope. So we replaced those servo motors with digital stepper motors, okay? And so these motors have a circuit board on them, and we can set the torque limit. So if it runs into something or hits something, or if the balance is so far off that it can't drive it through it, it sounds like it's tearing something up, but it's not. That's just the sound of the digital motor stopping and starting. That's all it is. And the circuit board processing. And so it'll make a chattering sound. Well, it's losing its counts, but it's not damaging anything. So you just electronically, left, right, up, and down, go back to the park position, turn it off, turn it on, close down the app, and close it in the background, reconnect to the tablet, launch the app, off you go again. No big deal. If it was a balance issue, fix the balance first, right? If it ran into your table, move your table, right? And then go on and do whatever it is you were doing. Those micro stepper motors are very powerful, because they can be regulated, right? Let's talk about how the go-to system works. In the old systems, you had a motor that spun, and it had a encoder wheel on it, a metal wheel with 256, I think it was 256 slits cut into it, and a light diode that shines continuously, and a light receiver over here, and it counts flashes. So when the wheels start turning, it's counting flashes, right? That's how it's knowing where to go. Encoder wheels are in use today. I had done some welding work in a Gerber baby food plant, and they use encoder wheels just like those. James Dugan, it's better than my Evolution Alt-Az mount when it loses connection with Wi-Fi. It spins like a Doctor Who Dalek gone mad. And Dalek gone mad, and you have to redo 3-star alignment. Well, you're going to have to do the same thing here, but hopefully it's not going to spin like a whirling dervish, right? That's what I think of it. And just
when it loses connection, it remembers where it's at.
But if it's lost, if it runs into something and
He
loses
said it
its
loses
motor count,
connection.
it doesn't, because the counts are off and it can't go back to where it came from. Where are you going to? You're going to something right now that's in the extreme northeast, right on the horizon. What'd you go to? M32? What is it?
Andromeda.
M31, I said M32. M31. Nailed that one. You went to the M31, the Andromeda Galaxy.
I'm just randomly picking stuff.
Just picking stuff to make it move. So those digital stepper motors don't rely on that encoder wheel system. They literally count microsteps. And it knows how many microsteps it is to go to any object in the sky. So if you start out with a good polar alignment and the counterweight bar straight down and the camera or telescope pointed directly at the North Celestial Pole, it assumes when it starts that you have that situation, right? It assumes a good polar alignment. It assumes
going to the whirlpool.
that your counterweight bar is down and the camera is pointed at the same spot in the sky. If you do that, you're going to get good, solid go-tos because you're meeting the required parameters for the motor counts to work. One thing that happens with telescopes especially, my finger is the left finger is the polar axis, my right finger is the telescope. If the telescope is pointed 3 degrees off to the east and not looking at the North Celestial Pole or South Celestial Pole, every go-to you execute is going to be 3 degrees off in some direction. Always, every time, 3 degrees off. And it's something that people don't think about. That's called, what is it called, Paul?
Huh?
What's it called?
What?
When your telescope's not pointing at the North Celestial Pole, but your polar axis is, or South Celestial Pole.
No idea.
Cone error. It's called cone error. So we are running up. Got a couple of minutes left. If you have any questions, give them to us real quick so we can answer them.
Messier 81 in Ursa Major.
M81 and M82, Bode's Galaxy and Cigar Galaxy. So here's an easy way. Make that map bigger on the screen, Paul. I can teach people real quick how they can find it.
Hang on. Where'd it go? There it is. Merge.
Here we go. So if you find the Big Dipper, right? And notice the diagonal bowls. See where the bowl of the Big Dipper is, Paul?
No.
You don't see the Big Dipper?
No.
Paul knows nothing about the sky other than it's up there. All right, so I'm going to walk over here real quick. Put your cursor on this star right here. Put your cursor on that star right there.
Come on, camera. There it is. This star right where?
No, I want the screen big so they can see this.
They can see
Oh, okay. This star right here.
Right there?
All right, that star right there.
This looks like a dog.
It's a bear. Head of the bear, right there where you are. 2 legs going down and a big long tail. Don't ask me, it is. In Europe, they call this the plow because it looks like a plow, or the wagon. On these 2 stars on the bottom right there, there's wheels right here. But here's how you find M81 and M82. Paul, put your cursor right here. See that? Draw a circle around that, right? And say, no, that one right there. Now, come to this star right here. Do the same thing.
Okay.
That star right there. Okay. Now then, measure this distance right here. Right? You got that? See, you imagine that distance. Now follow that same line up, that same distance. Right there is where you find M81,
this
M82.
doesn't look like the Big Dipper to me. Looks like a dog.
The Big Dipper.
Tail.
Right here's the Big Dipper.
Oh.
Right there's the Big Dipper.
This is the Big Dipper.
Yes.
Yeah.
So if you follow these 2, so you've got the arc of the handle.
I want to
These 2
know
stars make a diagonal.
who is going to put the lines in the sky so I can see these.
We do. On the app.
Never mind.
On the app. All right, have we got any questions come in, Paul, before we close down?
No, but I can get the next. See, I like this because this is cool, I think, because you can, well, once you get it polar aligned, if you don't know anything about it, you don't have to learn it, but you can
Need to learn
take
it
a tour of the sky.
and start learning.
Sure.
But you've got to learn how to polar align it. Get at least a good, rough polar alignment for this to work. Now, if you don't have a good polar alignment, you're going to have to use left, right, up, or down to get it centered up and go on down the road.
What does this look like whenever you get up on it?
What?
What I'm looking at.
What are you looking at right now?
Is it just the same thing, Kent?
You're looking at
just
another.
look like stars?
It's a star. That's a star.
Messier 108.
M108 is a M108. What does it say it is? Does it have information on it?
M108.
M108 is.
I don't know.
I can't remember what M108 is. I can tell you in just a second. Hang on. Menu. I'm going to do it. See, I'm not connected, so it doesn't matter. Messier M108.
Just stars?
M108 is a barred spiral galaxy in the constellation Ursa Major.
Oh.
It's a barred spiral galaxy.
What does that
Edge
mean
on.
exactly?
It's a spiral galaxy with a, imagine a gold bar. The center of the galaxy looks like a bar. So it's a spiral with a bar in the middle of it.
Okay.
I think we're starting to have power issues because of batteries.
No, I kept changing the target midway before I let it land.
The pitch, it's changed pitch in the motors. So, anyway.
The battery will tell you how much charge it's got.
It's got a couple of lights. Anyway.
I need to charge that. You need to get me a charge cord so I can take this with me.
This is how it works. It's real simple. Over in the carousel, if you're on Amazon Live right now, you pick one up for $599. They are ready to ship. We'll get it out to you next week. You know, they are, I cannot tell you how easy it is. Can you go out there on Telescope forums and find people who say it's less than perfect? Absolutely. You can do that. There's some people who think Fords are terrible and Chevys are the best thing under the sun, and there's people who think Fords are great and Chevys are terrible. It's just part of it. There's going to be people who are going to put something down, especially something new, or if they're really, really brand loyal, they're going to put something down because it's another brand, just like Chevy and Ford, part of it. Explore Scientific provides tremendous support for our products. You can go on the Amazon.com platform, go to the Explore Scientific store, or click the Contact Seller button. That's going to connect you up with Noah Menard, and he is going to hook you up with one of our trained customer service folks. If it's with the Exos 100, probably going to be Tyler or myself, or maybe Annie.
I'm going to the Crab Nebula.
Going to the Crab Nebula, M1.
Yeah.
M1, there you go. So,
isn't it cool?
Paul, it is cool. You know, it's just
Park.
It's just very cool. It works. You're seeing Paul do it right here. You know, the hardest part is doing that polar alignment, getting that polar aligned. Fairly easy if you live in the northern hemisphere and learn Polaris.
Well,
and here's the way you can open this port. Look through there. If you see Polaris in the
sky,
port, you're good. Now, what I do is I take a green laser, like I use to point things in the star, and I just shine that laser up through that hole. And after dark, I can see that laser going up into the sky, and I go, oh, I'm not pointing quite at it. I just move the mount till I'm pointing at it, and I can get a good alignment that way as well.
Well,
very simple.
And if you have one of these and you're using it at, say, home or the same place all the time, you can mark the ground.
Absolutely.
And you're just
Paul.
done.
I know people who have done things like they'll drive a piece of rebar into the ground, you know, and so they know which side they're going to put it on and put it right next to it so that they can mow over it, but yet they can go out and put the tripod down. You know, Tyler built a pier in his backyard, a big old concrete base and the pillar sticking up with a mounting head on it so he can go out, move his telescope out, set it down, it's automatically polar aligned, and off he goes. There's all sorts of ways to do it. All right, I've got an appointment to get to, so we're going to fold up our circus tent and go into the weekend. Everybody out there who's been watching, we truly appreciate you giving us your time because it is a gift to us. We love talking to folks and hearing the feedback and answering questions. It puts us on the spot and keeps us on our toes. And like the question about the hand controllers, I never would have talked about that, but I did because one of y'all asked about it. We truly appreciate you. We're blessed by you. Have a fantastic weekend. I hope it's safe. And that way we see you back here at 2 o'clock Central Time on Amazon Live. On behalf of everybody here at Explore Scientific, especially over in the control booth, the disembodied voice of Paul Newton, who makes all the magic happen behind the cameras, and once again, Noah Marketplace Menard, who keeps the Amazon platform up and running. He's spinning a lot of plates, but Paul's spinning a lot of plates, and he's juggling too. I'm Kent Martz. Have a great weekend, everybody. Bye-bye.